Number 1, it says express the system as a matrix, and then use Gaussian elimination by hand to get the matrix into row echelon form, and then back substitute to find the solution. So if you look at the box above, row echelon form, this has a diagonal of 1s with 0s below it. It could also have a row of 0s. Sometimes it will have that. Reduced row echelon form is something else, where we have a diagonal of 1s with 0s above and below it. So our goal is to try and get this into row echelon form, and our Gaussian elimination operations are to add a non-zero multiple of one row to another, multiply a row by a non-zero constant, and to interchange the positions of the two rows. Now, this is very similar, it's actually identical to the operations that we were doing in the last section, 10.2, with the systems of equations. And our process today is actually very much the same, except for it's going to look like a matrix instead. In fact, if you look at the row echelon form that we're trying to get into, that actually corresponds to a triangular matrix, which we were trying to get to, a triangular system, which we were trying to get to last time. So our steps, we want to get 1 in the first column of the first row, and 0 for every entry below it. Get 1 in the second column of the second row, and 0 for every entry below it, and then get 1 into the third column of the third row, and then back substitute. So our goal is essentially to get this into a triangular system, or a row echelon form matrix. So again, a lot of the steps are going to be very similar to the last worksheet. It's just we have a matrix instead of a system. So as a matrix, this is really going to be just the numbers in front of the variables. I'm not actually going to write the variables. So this will be 4, 8, negative 4, and 4, 3, 8, 5, negative 11, negative 2, 1, 12, and negative 17. So my first step is I want to get a 1 in this location. And I can do that if I multiply row 1 by 1/4. So I want to do that. I want to do 1/4 times row 1 to get my new row 1. So that should get me 1, 2, negative 1, 1, and then 3, 8, 5, negative 11. So the other rows are not changing. Again, this is very similar to last time. Okay, so once you get a 1 in that upper left corner, we want to get zeros all underneath it. So what that means is I want to clear out these numbers here. So let's first worry about that 3. So if I want to eliminate that 3, then I could take row 2 and add negative 3 times row 1 to get that new row 2. So having that 1 there makes it easier to eliminate those numbers. So if you kind of look at it, I have 3, 8, 5, negative 11, and then negative 3, negative 6, 3, negative 3. I add these up, and I get 0, 2, 8, negative 14. So that'll be my new row 2. So 1, 2, negative 1, 1, 0, 2, 8, negative 14, So I have the 0, or the first 0 underneath the 1. Now I need to get the -2 to be 0. So I'm going to move to the next slide. And to do that, I want to take row 3 and add 2 times row 1, and that will be my new row 3. So that's going to be having some technical difficulties here. That will be -2, 1, 12, -17, and I'm adding 2 for -2 and 2. So that's going to give me 0, 5, 10, and -15. So let me update my matrix. So now that I have the 1 with the zeros underneath, if you look back at the steps, I want to get a 1 in the second column of the second row. So that means I want to change this into a 1. So I can do that if I just take a half times row 2 to be my new row 2. So my new matrix is going to be this. Okay, so once you get a 1 in that position, you want to get zeros underneath it, meaning I want to get rid of that 5. So in order to do that, I'm going to take row 3 and add -5 times row 2. So I'm using that 1 to really eliminate all the numbers underneath it. And that's going to be the new row 3. So that's 0, 5, 10, -15, and 0, -5, -20, 35. So I get 0, 0, -10, and 20. So that's my new matrix. Again, we only update one row at a time. Okay. So then, lastly, I want to get a 1 in this position. So I can do that if I take -1/10 times row 3 to get the new row 3. So I'm going to the next slide, and this will be my matrix. So this is my matrix in row echelon form. Now, there are different correct row echelon forms, meaning you can get ones in this diagonal and get different numbers here. So if you have a slightly different answer, it is possible that your answer is still correct, but it's also possible that it's incorrect, just that there are multiple answers. So if you did like a different order of operations or something, you could get a different answer. Now, again, this really does represent a triangular system. So if I convert this back into a system of equations, this will be x plus 2y minus z is equal to 1, y plus 4z is equal to negative 7, and z is equal to negative 2. So again, this is that triangular system that we've been trying to get. And the reason why we want to get that is because we can back substitute here. So I know z is equal to negative 2. If I substitute that into the one above it, then y plus 4 times negative 2 is equal to negative 7. Y minus 8 is negative 7, and y is equal to 1. So then if you take 1 and negative 2 and plug them into the top one, x plus 2 times 1 minus negative 2 is equal to 1. This will be x plus 4 is equal to 1, or x is equal to negative 3. So my final answer would be negative 3, 1, and negative 2. So again, very similar to last time, just that we are not writing the system of equations every time with the x, y, and z. We're just expressing them as these matrices.